Okay, let's go ahead and start section 4.2. We're going to talk about exponential functions. We have three basic goals in this section. The first goal is to graph the basic exponential functions and their transformations. And the second goal is to solve equations with exponentials. And the third goal is to talk about application problems involving exponential functions. So we'll focus on this first goal, the graphing, here in this first video. And to begin, let's talk about the definition of an exponential. There's a formal definition here which says that an exponential function looks like f of x equals a to the x, where the base a is a constant, not equal to 1, greater than 0, and not equal to 1. Another way to say this is an exponential function is a function where the variable is in the exponent. And so it might be worthwhile to write that here on the side. The variable is in the exponent. And so in just a minute, we'll look at the function y equals 2 to the x. Variable is in the exponent there. And then I would just encourage you to think back on a function we've studied a lot this semester, y equals x squared, and see how close how close they look to each other, but how different they are. X squared with the variable in the base, and now 2 to the x with the variable in the exponent. Okay, so there are two basic exponential functions. We'll talk about 2 to the x first, and then we'll also talk about 1/2 to the x. And so to begin, let's just go ahead and make a table and a graph for y equals 2 to the x. So we need to be pretty good with properties of exponents, and so we'll try to highlight those as we go along as well. So let's see here. If we have 2 to the negative 3, we need a property of exponents right off the bat to deal with that. Maybe we'll skip that for just a second. So let's come down here to the bottom of the table, and we'll plug in x equals 3. 2 to the third is 8, and we can go up the table. 2 squared is 4. 2 to the first power is 2. Anything to the 0 power is 1. And then we have these negative exponents that could be a little bit tricky. What we want to do is remember the property which says a to the negative n is equal to 1 over a to the nth power. And so if you have 2 to the negative 3, that's the same as 1 over 2 cubed, which is the same as 1/8. And then similarly, you would get 1/4 and 1/2. And so then we can go ahead and plot these points. Maybe I'll start in the middle at 0, 1, and I'll go to the right 1, 2, and 2, 4. 3, 8 doesn't fit on the graph. That's okay. Negative 1, 1/2, and negative 2, 1/4. And then we could try to graph negative 3, 1/8, but we're getting so close to the x-axis that could get a little misleading as well. So let's just stick with these 5 points, and let's connect a nice smooth curve through the points. And there's our graph. So this is f of x equals 2 to the x. And let's see here. We should notice that the domain is all real numbers. We can raise 2 to we can use any real number as the power in this function. And so all real numbers, negative infinity to infinity for the domain. For the range, we see that the y values are always going to be positive. The x value can be negative, but even when the x value is negative, the y value is positive. So 0 to infinity. And let's see here, there's an x-intercept at 0, I'm sorry, that's a y-intercept at 0, 1. There is no x-intercept. As we come out to the left end of the graph, we get closer and closer to the x-axis, but we never quite get there. So there is no x-intercept. The y-intercept is there at 0, 1. And then as we get closer and closer, as we go out to the left end of the graph, we get y gets closer and closer to 0. Well, that's exactly the definition of a horizontal asymptote. So we have a horizontal asymptote here at y equals 0. You remember horizontal asymptotes from studying rational functions in chapter 3. A rational function always approached its horizontal asymptote at both the left and the right ends of the graph. This is not the case anymore. This exponential function only approaches its asymptote at one end of the graph. At the other end of the graph, you can see that the y values are shooting up toward infinity, not getting closer and closer to some fixed number. Okay, so there is the first basic function. Let's go ahead and work on the next one. The next one is y equals 1/2 raised to the x, and so we can plug in 1/2 to the -3. And so let's see here. That could be a little tricky. Maybe we'll come back to that in a minute. Let's start at the bottom of the table again, and maybe we'll have an easier time. So 1/2 to the third is the same as 1/2 times 1/2 times 1/2, or 1/8. And then similarly, we'll get 1/4 and 1/2, and 1/2 to the 0 is just 1. And now we're back to those tricky negative exponents. So let's see here. 1/2 to the -2 is there in the middle. And we already learned up above that a to the -n is the same as 1 over a to the n. Well, it's not too far off for us to conclude that if we have a fraction, actually let's change the pen color and let's put it up here. If we have a fraction a over b to the -n, then that's the same as b over a to the +n. So if we have 1/2 to the -3, then that's the same as 2 to the 3rd power, or 8. And then this one would be 2 to the 2nd is 4, and 2 to the 1st is 2. Okay, so we can go ahead and plot those points. Again, I'll start in the middle with 0, 1. I've got -1, 2, and -2, 4. I won't worry about -3, 8. I will graph 1, 1/2, and 2, 1/4. I won't graph 3, 1/8 because it's just too close to the x-axis to be very meaningful. So then here's my graph. It looks very similar to the first graph. The only difference is it's, well, I guess it's a reflection over the y-axis. It's a horizontal reflection of the original graph. Okay, so at any rate, the domain and the range will be the same as before. Domain is all real numbers. and the range is the positive real numbers. There's still a y-intercept at 0, 1. There is no x-intercept. And then we see the behavior of a horizontal asymptote as well. As we look out to the right end of the graph now, the y values get closer and closer to 0. So that tells us we have a horizontal asymptote at y equals 0. Okay, so those are our two basic functions, and we can generalize a little bit if we just want to talk about the basic shape of the graph of any exponential function. So if the base is greater than 1, then we can think of y equals 2 to the x, since 2 is greater than 1. That's a good number to think of. And then the graph is going to look like the graph we just drew. And again, it doesn't matter if it's 2 to the x or 10 to the x or 1.5 to the x. The basic shape is the same. The basic shape is the same. So there's a y-intercept at 1, and there's a horizontal asymptote at y equals 0. Okay, so we need to know that graph, and then if we have y equals a to the x where a is between 0 and 1, then we should think of y equals 1/2 to the x, and it doesn't matter if the base is actually 1/2 or 1/4 or 5/9 or whatever fraction or decimal you'd like to think of between 0 and 1. The basic shape of the graph is the same. It's this right here, with a y-intercept at 1 and a horizontal asymptote at y equals 0. Okay, so so that'll just about do it for this first video. I just want to look ahead to the next video. We'll start the next video using transformations to sketch the graph of a more complicated exponential function, like -2 to the x plus 3. So come back for the next video to see that.